All right, and hello everybody, and welcome. I'm glad you're here. Most people would say do not start out with a complex chemistry statement. Polyoxymethylene, POM, thermoplastic engineering material. Also, I think it was invented by DuPont, or at least they got the first name on it and called it Delrin. It's also called acetal polyformaldehyde. It's a plastic. It's used for bushings. It's used for a lot of things, but that's what we're going to be talking about, and we'll get rid of that. All right, and you got to admit that's kind of pretty. Of course, I always think it's pretty because I drew it, but this is a tube of polyoxymethylene Delrin plastic. And we have taken a CNC machine and put a groove in it on each end. It has inside of it a smooth shaft. This is a piston rod. The piston rod has a stabilizing bearing and a fluid seal on it. And the way we're going to put this together to make it into it, this is a hydraulic cylinder that we are using for the purpose of experimentation to prove that hydraulic cylinders are an acceptable method to be the prime mover of a robot. And so these two orange metal pieces, they have these little ridges in here, and they have these bolts right here, and these two orange metal pieces fit directly into that groove. And when you tighten down these two bolts, this one and that one, it clamps this to that, and you wind up with a structure that looks like this. And then these screws here take this purple end cap and pull it against this clamp, and in there, I don't know if I've shown it, but in here is an O-ring, a square cross-section O-ring. So this is being pulled against a square cross-section O-ring, and the O-ring is up against the Delrin, and this has a hole in it where you can screw in a fitting, and that allows you to put hydraulic fluid into the Delrin. And this piston rod will have a piston on the end of it, and on the other end, again, there's the O-ring right there, and on the other end, this comes out through a sealing, not sealing like what's above your head, but a seal, so that this piston rod can go back and forth. And it has in it another access port right here that allows hydraulic fluid to go in there. So there you go. And of course, I always like to look at where are we, and that's nice. What is this? Aspens of White River in Colorado, and it is a clear demonstration. I absolutely can see the trees for the forest and get deeply inside of the tiny little details of this and that, and I'm trying to show you the entire forest, but I prefer being in there looking at the trees, and so that's what this is, and we'll do some more discussion. And of course, every time I really am. I'm glad you're here. Welcome. Enjoy. I do have a YouTube channel. I invite you to subscribe. I think you'll like it. I do have a website, and I have pages on my website, and this is the page where we're including this discussion about the weight of the robot. I put a few of them down here just for fun. These are my mannequins. They put on the robot feet to show off. I do like to remind everybody we are talking about a physically real item, and any physically real item has the potential to hurt somebody. And my advice is, anytime you are managing a physically real item, you should manage it. My advice is manage it in a manner that is legally allowed and reasonable and safe. And if you can't manage it in that way, then my advice is do not create it as a physically real item. So let's go look at some stuff. So this arm of this robot can pull on this shoulder of this robot with 6,000 pounds of force. Now that is a robot. Again, why are they making this robot? It's a mystery to me. It's just confusing. I think they've convinced themselves that it can't be done, and they're just wrong. But I know I have to prove it, and so this I will. Oh, and so let's go look at this in Maya to be sure that it really works in Maya. And so this is what it looks like in Maya, and again, I've found in Maya. This is Maya importing the FBX file from SketchUp. And there you go. See, it even imports within reason. It imports the cubic inches. It's interesting. See, that one it did. This one's a little bit. But apparently there's a way in Maya for Maya itself to tell you what the cubic inches are. I did not know that, but there they are. So it imports into Maya, the FBX does. So, and Maya can export each one of these objects as an STL file. So you can print this robot if you want. Another thing about my designs, I make my designs so they don't have an intrinsic scale. So if you, as long as you take the entire robot and shrink it, you can make a version of the robot that's only 2 feet tall if you wanted to. So now here is my website. I like the feet. I think they're kind of pretty. So I just put them as images that show up in the website. Hi. I have an area of the website that's not related to robots and an area that's related to robots. And then I worked on an engine to pressurize the robot. I just think that's pretty. Okay, so here on my website is the robot walking along. And so I'll click on that. You can download this, 124 megabytes. If you click on this, you can download it. It's been downloaded by 3,516 times. The question I don't know who downloaded it, but I did not think that was going to happen. All of my stuff I put on my website, but here it is walking along. And I created this by simply making poses of the robot as it walks, and then doing a basically a frozen motion or a clay motion, stop motion video. And this is the robot walking. And at the time I made this, the robot didn't have arms, and it will have arms. But if you look at this robot walking along, you will notice this is how human beings walk. The way that they have the current crop of human mimicking robots, they don't walk like this. And I think I know why. I think it has to do with the electric motor gearhead systems. See the pelvis going back and forth, and the abduction, adduction of the legs, and the internal, external rotation of the legs, and the eversion, inversion of the ankles. All of these things are happening. You'd have to look at those hydraulic cylinders to see it. But that's what human beings look like when they walk. And there isn't a human mimicking robot on the internet that walks like this. And I just keep saying, what is going on? And I mean, I think I know why, but they're so happy with their walking robots. There aren't any robots that walk like this. And why is that? All right, and the question becomes, what do I need exactly? There is a company named iGoose. I don't have any financial connection to this company. It's just well known for these polymer bearings. And they make a polymer material that they call iGlide. And they go over their bearing materials and they go over what they are, and they have technical chemical compositions. They're basically acetal polymer Delrin, and they add fiber to it, and they add granules of materials that release lubricating material. And this, I don't think we need to use iGlide. It's expensive. I don't know why we couldn't use Delrin. Delrin's available as blocks of material. It is machinable. All right, and this is, we're back in SketchUp, and this is a drawing. I was working on a micro valve for the hand. That's a separate issue. But what I need to do is establish that you can make a cylinder of this acetal polymer material. Okay, there's that cylinder. Again, I add colors, I lower the opacity so you can see through it. So there is a cylinder of that acetal material, and inside that cylinder is this stainless or aluminum material that has this shape to it. It has a smooth rounded edge here, because if it didn't, it's going to dig into the polymer. And it fits inside of this acetal cylinder. And I need to work through this. This end cap has to have a gland on it and a cap to seal this end cap against this shaft so it doesn't leak. And we have to have the way to get hydraulic fluid in here. This one, it might be, could just be sealed. But what I have to demonstrate is that if you put pressure in here, it will move this structure back and forth. And what I don't know is, if you know this diameter, and these are, I made them large because the program, it's easier for the program to show it when it's large, but it wouldn't be 4,000 millimeters. It's going to be a ½ inch. But if that's 0.500, the question becomes, what does this have to be? It can't be 0.500 inches because it would leak. It needs to be 0.508 or 0.510. It has to be a number of thousandths of an inch bigger than a ½ an inch, so that you put some pressure on this and force it into that cylinder. And the squeezing of that Delrin cylinder against this piston seals it, so that pressure on this side does not leak across the piston. So that's the first thing that I need to build. And that will allow me to do, because I don't need, in the real Pistonrobot, this would be surrounded by a metal cylinder to make it strong and safer, but I don't need that. I just need to show that you can make a hydraulic system. You can make a piston rod and piston head go back and forth inside of a Delrin cylinder. That is the first thing I have to prove. The second thing I have to prove is, how do you sense the position of this piston head, piston rod inside that? All right, she has picked up that rod of Delrin and lifted it up. Boy, I hope I'm not in trouble. Oh no, she's pointing at the clock. I see, I'm out of time. All right, we'll stop and start again with another one.